Good afternoon, ladies and gentlemen. Welcome to this afternoon session on ITS for urban mobility, where we will have 5 speakers. The first speaker will be Mr. Jan Reitsma, sorry for the pronunciation, of the Sensor City Foundation. And he's the director of the Sensor City Foundation and leads the development of a urban sensor network in the city of Assen in the Netherlands. He has a nice experience in project management functions on commercial, industrial, space, and military programs. Please, the floor is yours.
Well, good afternoon. I'm Jan Reitsma. I'm the director of the Sensor City Foundation. And I will start the presentation with a short movie. And a short movie will explain what is Sensor City as a living lab. So please watch the movie, and after that I will come with some sheets.
This is Assen, a picturesque city in the north of the Netherlands with a rich history. But Assen is also the world's first sensor city, with a demonstration and innovation platform in the field of sensor technology. That sounds complicated, but it basically means that the city is covered in sensors. This was Assen in 2010, and this is Assen today. A large number of Bluetooth sensors have been put in place. These Bluetooth sensors help to provide an overview of traffic flow at intersections and transit roads. Additional Bluetooth sensors in parking garages are used to study which routes are taken to access the garages. This information can, for example, enable more effective signage. But that's not all. Sensor City also has cameras. The cameras provide a detailed picture of the various incoming and outgoing traffic. They register the intensity of various traffic flows and can be used, for example, in car parks for license plate registration. Audio sensors have been installed for other purposes. For instance, to paint a picture of the city's sound environment. Analyses of traffic, weather, and human and animal noise can help to predict the auditory experience and to eventually control noise levels. All gathered data is sent via a terminal to the control center. With all these sensors and a citywide sensor network, Assen is one big testing ground. Or you can say, Living Lab Assen. It enables the testing of various applications, which can then be implemented nationally or internationally. A good example of this is the cooperation between different parties involved in transport, who together have developed new applications for navigation systems. Faced with hold-ups on the road, drivers can use the so-called multimodal travel assistant to determine whether taking public transport will bring them to their destination quicker. Another application is the onboard unit, which gives information on the number of empty seats in cars. This system is currently being used in Brussels. Via this system, it is possible to offer or book a ride, and so reduce the number of cars with empty seats going to the city. Of course, the possibilities are endless. Think of sensors that can measure light intensity, rainfall, drainage, or particulate matter. Other possibilities include the connection of smartphones through the use of apps. Sensor City provides the opportunity to test many of these applications. Cities, companies, and networks that are looking for solutions to urban problems with regard to mobility, quality of life, healthcare, sustainability, and security can find in Assen a ready-made testing ground, a living lab. Sensor City Assen. The quest for the answers of tomorrow begins in Assen.
Well, I hope that this movie, the short movie, explains what Sensor City is as a living lab. A living lab is basically it's an urban test platform. Basically, if you connect all kinds of sensor systems to the basic infrastructure, you create basically a domain. So if we connect all the traffic sensors related to mobility, we have created, as you see in the top, a mobility domain. And we are able basically to present a test platform where you can develop all kinds of application and new services in mobility. But it's more than mobility, because if we connect weather sensors or other type of sensors, we create another domain, another environment. So I will go shortly through the possibilities of what kind of applications you can develop, you can verify, and what kind of new services you are able to do on this test platform. Well, the Sensor City network is basically covered all over the city, and if you see those lines, it's a fiber network, and that's basically meant to have enough capacity to have all real-time streaming information going through the network. Well, for the mobility domain, we have basically connected all the traffic sensors related to the traffic and mobility in the city. We have connected to Sensor City. And by that, we have created a test platform where we can develop all kinds of mobility applications. But it is more, because at this moment we are also connecting weather stations, and we are measuring the wind speed and the temperature, the relative humidity, and we are measuring the light intensity, and we are measuring the sound. So basically we are determining the environmental conditions of a city. And by that you can correlate also all kinds of information. What is the influence of light or weather on mobility, and the other way around. So basically by that we have created a citywide test platform where you can do all kinds of citywide experiments. I'll go quickly through the majority of the activities done so far is in the mobility domain. By basically having this network available, you are able to basically monitor all the traffic flows. And you can develop all kinds of scenarios and algorithms for the traffic management systems. We have running two parallel models, and you can also do predictions. And you can predict what basically the traffic flow will be within a certain amount of time. And by that you can basically determine new scenarios for cities. Very hot topic, and especially in the Netherlands, because we have a lot of bicycles, is basically the problem of the cycling flows in the city and the uncontrolled cycling flows in the city. And by that we're basically going to do experiments where we have more understanding in how the cyclist is behaving itself in the city. And by that basically determining if we have to do measures and what kind of measures are really helpful. And by that, the next step is basically that we are also using the citizens of Assen as part of the experiment. So we have continuously an interaction with the participants. This is starting also, is basically what is the effect of particulate matter in a city. And we do not have full understanding of the behavior and the modeling for particulate matter spreading out all over a city. And by that we are going to do a measurement all over the city, where we basically are going to look for, with a high sophisticated company, about understanding what kind of interactions are there. What is the interaction of weather in the city on particulate matter? What is the effect of mobility on this item? And by that we are basically have the possibility to get more understanding in the problems. Sound. As you saw in the movie, we are recording basically the sound of all the city. And by that we can determine the hotspots, and we can determine what is the quality of living in a city with respect to the sound environment. And I have to look for this. Before I close, I hope you have an understanding, because the time is really short for this kind of presentations, that Assen is a living lab where you can do all kinds of experiments, where you can come to develop or to verify your new products, or to get more understanding before you roll out to the bigger cities, to the real the big smart cities. I invite you also for this evening. We have a meet and greet in a hotel, and if you have questions and all, make sure come to this evening, because then we are able to explain in more details, basically, if you have still some questions. And I will thank you for this for time for presenting this Sensor City Assen.
Now we have a couple of minutes for at least 2 or 3 questions from the floor. Please use the microphone over there to ask your questions. Okay, please.
Hello, my name is Gladys Frame from the World Bank. I'm just interested in the nature of your sensors. You talk mainly about Bluetooth and Wi-Fi, but you also had a passing reference to a wired network, a fiber optic network. Was that planned in advance, or did you foresee that? How difficult has that been to do, or is there a future for FO?
If I understand your question, it's the creating of this network was planned, basically, yeah, because we were basically planning to build a city-wide area sensor network in order to stimulate economically, stimulate companies, but also to get more understanding in the problems related to the phenomena, also the city problems. And so basically it was planned. Creating a fiber network in all kinds of cities is basically very expensive. You want to avoid that.
Yes, yes.
But if you do experiments, you must have enough capacity and bandwidth to do the experiments. So that's why we have created the network. But we are also looking to other techniques so we can expand and roll out in other cities, not using fiber optics.
Yes, my point is that, retrofitting a fiber optic network is expensive and difficult, and, many cities have planned many years ahead, but now some cities are trying to retrofit, and I wondered your experience on that.
Now, well, we have more experience because we are now looking to integrate it in the traffic systems.
Yes, yes.
Because the traffic system basically is spread over the city. And if you're using the control parts of that traffic management system, there basically you have your access points, and you go to the wireless connection sensors. You are connecting wireless, and you collect them in the traffic management systems. So this is basically our first experience in retrofitting it in other cities.
And do you own your fiber optic network or lease it?
No, we own it. Otherwise, you get all kind of discussions. Yeah.
Okay, thank you.
Well, thank you very much for your answers.
You're
I'm
welcome.
sorry, but we ran out of
time.
time. If you have any other questions, please follow
Come this
indication. Our next speaker will be Mr. Gilles Vesco, councillor and member of the board of the Greater Lyon urban community, is in charge of the new urban mobility.
Just okay. Good afternoon, everybody. Thank you for your invitation. My purpose would be to tell you how much digital information is critical to urban mobility everywhere, but specifically in Lyon, by actual exemplification. Yes. So as you know, urban mobility is the result of many constraints, needs, and triggers. In Lyon, we have many cars coming into the city every morning, and 4 million travels a day. 1.6 is made by public transport, and all the rest is individual car and other means. We are managing to have a decrease of 20% of road traffic since last 10 years, and we are planning to do the same thing for the 10 coming years. That's to say 40% in 20 years. But still, at the periphery, the problem is big and full. Although it is the same question for all the cities. As for pollution and public health, we have improved the air quality background, but we've got to improve NOx and particles. So our main goals, of course, are accessibility of the city and reducing environmental impacts in the same time. and through the reconquest, the reclaim of the public space, especially for soft modes, active modes. We've got 2 rivers in Lyon, so we are reclaiming the river banks, to taking the room from the car, the parking car, and giving it to the pedestrian and the bikes. So that's, so to say, creating or recreating, rebalancing the public space to have new spaces with no car or no speed. The aim is acting on demand, of course. That's to say individual behavior, by building credible alternatives to individual car use through land planning, as I said, and through new mobility services that induce, foster, or some would say nudge, new behaviors from the public. And what I'd like to put on your radar this afternoon is that digital information, what we call intelligence, is critical to providing cleaner and better shared modes of transportation. So it's critical to urban mobility, which challenges are so huge, actually, that it can only be a mass challenge. The challenge is the public, and there's no other reset button. Just to say that sustainable mobility is working only when everybody's coming along. And that's, by the way, the very definition of sustainable development. Otherwise, it's just wishful thinking. As the sociologists say, information on mobility is 50% of mobility, I would say 100%. And sharing is the keyword. Sharing is what is occurring in the improvement zone, the black triangle that you see, and this information, this digital information, must be shared to be efficient. So that shared intelligence has become a pleonasm. So sharing information, not holding back information, which was synonymous of power, that was in feudal times, today also. The power of changing things, of course, in mobility, is to share information, not holding it back. So sharing information to better share modes of transportation and to better share the city itself, the public space, which is the final cause of all this, and of course the air we breathe. So sharing information is crucial to embracing citizens' involvement. And since citizens' involvement is crucial to this game shift, you've got to build, credible, I just switched one slide. You've got to build credible alternatives to foster this model shift. So new transport services, like we invented in Lyon, the one-way individual public sharing bike sharing system called Vilov. It was like Vélib in Paris, but 2 years before, 4,000 bikes. The figures are exploding. That's this one-way system that allows this level effect for bike practicing, with, of course, the rebalancing with bike lanes, bike tracks. But when you provide both in the same time, the figures are exploding. And this digital information, of course, is fully integrated in those new services like bike sharing, but car sharing also, ride sharing, also in public transport now. And actually, digital information is this kind of thing you put into a rolling machine to better share it. Digital information is also travelers' information. That's the second form that takes digital information, travelers' information. But in order to do this, you've got to break down the silos and collect and connect. Collect with sensors, for instance, and connect everything. The value relies within the connection of the data. And then comes the funding policy, of course, PPP, public-private partnership, and private-private partnership, thanks to those sharing systems, collaborative platforms that provide rolling machines or information as travelers' information. PPP in the spirit or in the written law is the key, since public money is getting increasingly scarce, as you know, almost everywhere. So modal shift means multimodal users, and if you want people to be multimodal, you've got to provide them with multimodal information. As you understood, individual car is the target in order to drag individual car drivers off their diesel private cars where they are riding alone in the morning. The average occupation rate of the car in Lyon in the morning is 1.02 people per car. So in order to show car drivers that there is an alternative, and making it quite simple to use by providing them quite simple information. So this information must be provided as targeted, embedded, first and foremost on oneself, real time, first theoretical time, real time. That's when you start you start now your trip. Predictive time. That's when you start in 1 hour, next hour. Anticipation is everything before it's too late. And of course, reliable, specific, interactive and information. So you've got to provide travel time and users' costs first. Then you can give CO2 and the weight you lose during your trip. Digital information first relies in new transport modes, but then relies in apps, in multimodal information that itself relies between the modes, interstitial between the modes, and that you build with big data, of course. Here comes the big data that you've got to collect, to connect through transport providers, which are also data providers. Access is the keyword. The access to the city itself will be the access to the information, and the fluidity of the city will be the fluidity of information. So connection is everything, is the value as a connection of data, of people, as you know, and then we store this data and we filter the use of this data as the Greater Lyon Public Authority to give back to real users that can rebuild new services on this data, like apps, for instance. So that's the way we are building Only Move, our mobility central of mobility, and our multimodal GPS individual urban navigator called Optimod, which is a mobile app that we are to issue in February or March with predictive time that we build, including thanks to sensors. So I'm going to the conclusion. Of course, sorry. You've got here the model along which we are building those cooperation, and you can see about PPP, about business models, that nobody can exist now in urban mobility without the private sector. No bike sharing without GSC Deco, no car sharing without Bolloré or Toshiba with the SunMove system in Lyon, no public transport without Gilles, which is a private company operating the network. We are rebuilding tunnels with PPP contracts, taxi bike, taxi pooling, or Uber now. And everything must be based in Lyon on electromobility for evident reasons. So this urban navigator OptiMod that we are launching will be crucial to the fluidity also. And those are sharing platforms that makes, strangely, that the addition or combination of all the individual interests makes the general interest, which never happens in the city. But when you go through intelligence, through those collaborative platforms, you can get this result. That's almost self-organization. That's not yet this, but we are heading to this. So we can better share in individual modes thanks to digital information and better individualize shared modes. And now I'm just finishing. Public money is scarce, as you know, and car capacity remains a great potentiality. The only empty place in the morning is car, as I said. So that's the ride sharing is a great potentiality, and you've got to provide information and build platforms to allow people to share cars. This car should be more connected, better shared, cleaner, and smaller in the future. And as I said, sharing is the new paradigm, and the key factor tomorrow for urban mobility. And digital information, as you saw, is everywhere into the new modes, in between the modes, as travelers' information, and thirdly, as a raw material itself, as a common good itself, like the shared bike, the public car, as a common good, like data, this raw material, upon which you are rebuilding new services. Thank you so much.
Well, unfortunately, we ran out of time, so there is no possibility of questions. If you have any questions, please ask him at the end of the session. And then we move to the third presentation by Vincenzo Marano, who is a research associate at the Department of Industrial Engineering at the University of Salerno in Italy. And he coordinates and conducts research on energy storage and management, plug-in electric vehicles, and their interaction with renewable energy sources and the grid. Please.
Well, thank you for the introduction, and thank you for the opportunity of being here. The work I will be presenting today will be a very quick overview of some activities that we are leading with Magneti Marelli Innovation. That's a company that's within the Fiat group and is focused on whatever is innovation in the terms of automotive. Specifically, I will be showing some opportunities of using ICT, so information and communication technologies, within the automotive sector. First, I should start with some definition. Let me also make it clear that I'm going a little bit more on, let's say, in detail with respect to the previous speakers. I guess coming from the academia, I go a little bit more in the detail. The first thing I want to introduce is what it's called ADAS maps. These are digital maps that contains information that go well beyond what we're used to see in our navigation systems. So these maps contain information like, let's say, slope of the road, number of lanes, the traffic density, and these kind of things. The idea of ADAS maps fits within what's called electronic horizon. Electronic horizon is a whole series of data and new information that can help the driver look at beyond what actually the human can see. So knowing what's actually happening beyond the next curve and so on. These kind of maps, as I was saying earlier, contain attributes like curve, slope, speed limits, the location of the traffic signs, the frequency of vehicle flows, and so on. The idea, so how the system works, the car has a GPS system that's able to locate the vehicle itself within the overall network. Once the car knows where it is, it will literally get the data that's needed to estimate what's happening in the near future. And EH, so the electronic horizon, will provide a protocol string of data going to the ECU, the car ECU, that will have to activate some specific applications or functions. With this diagram, it could be easier to understand all the different pieces of the puzzle. So once the vehicle understands what it is, it will merge the position with the ADAS maps and will then push the information towards the, let's say, the intelligent part of the vehicle. So now the vehicle can see the road network and the probabilities for the vehicle to get that specific road. That means there are different ways of understanding, or let's say estimating where I could go. One option could be looking at traffic data, looking at what most people do, so that's probably what I will do as well. But on the other hand, there could be some self-learning tools, algorithms, that are able to understand that maybe I'm different than other drivers and learn what I usually do once I'm on that specific point of the street. All of this, of course, is merged with sensors or V2I and V2V infrastructure. So, of course, the data is key in the overall process. And there is, of course, a process of data fusion. And with all of this kind of data, there will be tools able to optimize what the vehicle should be doing. So in the previous presentations, we have heard about what we can do with the data in terms of, I would say, higher level management. In this presentation, I will give more details on what we can do managing the vehicle itself. This is an example, a simple example of what let's say the algorithm will see. Once you are at the point 0, so where you can see the green car, there are different ways, the different pathways that I can take. And on each pathway, the algorithm will tell me what's happening. The other information that you see highlighted in yellow represented what's called the dynamic electronic horizon. That means information that are coming from sensors, are coming from the V2I or from V2V, so vehicle to infrastructure or vehicle to vehicle. And there are actually, as I said, dynamic information. And with all this kind of information that I have, now I can decide which path to take, and within each path I can optimize the behavior of the car. The way we optimize the behavior of the car, it's actually meaning suggesting the optimal speed and the optimal gear shift that you should use. So once you know where you're going, you know exactly the energy you need in that specific path, there are combinations of speed and gear that will make that path, in terms of fuel economy, the most efficient way of doing it. So, of course, there will be different ways of doing this. It could be just a suggestion to the driver, like this is the speed you should keep, or think about an intelligent cruise control where the vehicle itself will decide the speed. So as I said, digital maps will provide what we call electronic horizon. Within the electronic horizon, there are algorithms that will be able to predict where I'm going. And where I'm going could be done through a MPP, that stands for most probable path, so it's what pretty much people are doing, or maybe eco-driving. So instead of doing what most people will do, maybe looking at CO2 emissions and looking for options that will minimize the emissions. As you can see from this diagram, we go from the GPS positioning. We identify where we are on the ADAS maps, on the digital maps. We will then optimize speed and gear for the vehicle. We'll then check if the driver is respecting the reference that we provided, and eventually adjusting the reference. Because, of course, if the driver is not following the advice itself needs to be updated. And this is all embedded in the vehicle control. There are, of course, different levels where the optimization can be performed. It could be onboard, so on the vehicle. It could be off-board, thinking about cloud servers and so on. A key piece of this overall idea is the driver behavior classification and identification. usually driver behavior has been in the literature for years, but mostly for fleet management, active safety, and fuel economy. And usually, as I said, it was for fleet owners, fleet managers, who wanted to understand how their drivers were using the vehicles. So the idea is to build a profile of the driver, to classify the driver based on different markers, let's say normal driver, aggressive driver, slow driver, and so on, and provide eventually feedback to the driver itself. Detect and classify, of course, dangerous operations of the drivers, and characterize the driving style. With all these pieces, you can also think about the car that will, as I mentioned earlier, the car suggesting you speed and gear. The car could suggest you speed and gear also based on your style, also based on the way you drive. And these overall tools also include applications to estimate driver's fatigue, to estimate if assess if the driver is distracted or is driving carefully, and so on. And this is for people who are used to work on vehicles and on control for energy management. This is a very new, I would say it's a paradigm shift, because drivers have always been kind of like a noise in terms of control, something that we were not able to control or manage. Now, not only we can eventually control the driver, but we can use the inputs from the driver as inputs for the controller. So this is changing the way that cars can be optimized in the way they work. And of course, the algorithm is real time, able to classify drivers real time, identify, and of course give feedback. Feedback could be also, you are distracted, be careful, or there is a curve ahead and you should not keep that speed, or things like that. So something that has to be also very practical, of course. And the idea is that the technology, of course, has to be affordable for most drivers. The last piece of the puzzle is represented by the integrated vehicle management that we're working on. Specifically, as I said, now that we think about having all the different pieces, you have the pieces from the infrastructure, you have the pieces of the driver. Now you could also manage how the vehicles can drive on the roads. Clearly, this is an application that's been traditionally used for trucks, so for bigger vehicles, but we also have some simulations and some results on regular cars. Without going into the details of what we have done, I mean, clearly we worked on the models, we worked on the communication between the vehicles, and what we have seen is that if you are able to find the right distance between the vehicles, you can get up to 15% of fuel savings. Now, 15% is a big number. People are working on cars, on engines, are working very hard to try to get an extra 0.5% or 1% from an engine, but you can easily get up to 15% if you just keep the right distance between one car and the following one. And of course, all of this should be done through a cruise controller and through some intelligent systems that will be able to manage, of course, the distance between vehicles. Now, the control has to be not too strong, I would say, otherwise you will end up accelerating and braking the whole time, and you will actually decrease the fuel economy. And also should not be too bland, it should be the right optimization problem, because otherwise you will end up not being able to control the vehicles. I see I'm running out of time, so I will go to the conclusions. Well, very briefly, I wanted to introduce the activities focused on ICT that we're developing with Magneti Marelli and University of Salerno. So as I said, this is a joint lab where industry and university are working together towards what the industry needs. I gave you some brief overview of what Electronic Horizon is, or at least how we see it, how we can use the data in an intelligent way. I mean, clearly we have plenty of data available, but the idea now is to do something with this data, do it in an intelligent way, not just monitoring, not just assessing things, but also trying to make our cars more intelligent in a way that we could save money, of course, emissions, CO2 emissions, and so on. And I mean, this is the reason why we're all here is because ICT will play a very important role in the automotive sector or mobility in general. So that's, I would say I can conclude with this. I think I was right in time.
Well, we ran practically out of time, but maybe one quick, but very quick question, if any. Well, then, if not, we will move.
There is one.
Oh, sorry.
Just a quick question. Have you ever tried to integrate that with urban transport operating for a urban transport planning and operation, like monitoring, because you are focusing on fuel consumption, but also trying to optimize the reduction of time for passengers, the time savings for passengers with the fuel consumption, and trying to reach like a comprehensive systemic equilibrium, maximize everything, not only the fuel.
Yeah, I'll be quick. Our idea is to integrate all of this in a traffic simulator, because we understand that if you can improve one vehicle and you can do that with all the vehicles, you are actually improving the traffic flow. We are not into we're not, let's say, specialists on traffic flows, so we see that, let's say, as a side effect that we will have to assess, yeah, for sure. I mean, that's something that we start from the small vehicle, and then we are sure that we can go to the overall network. So.
Okay. Well,
okay. Thank you very much for that.
Thank you.
Thank you for the presentation. And then we will move to our fourth speaker. That is Mr. André Diaz. He's Head of Intelligent Systems at CEIIA, where he coordinates the development of ICT systems and intelligent mobility projects across Europe and Brazil. He is also in charge of the technical manager of the Portuguese e-mobility project.
Thank you very much, Jaume. It's a pleasure to be here once again this year. And I'm taking you on a journey through MobiMe, which is basically our mobility management platform. And I'll give you some insights of what kind of things we have been doing, mostly in our newer projects in Brazil. So, sorry. This one? Okay, first of all, for those of you who don't know CEIIA, we are Engineering and Innovation Center based in Portugal, and we work in two big industries, the automotive one and the aeronautics. So our background comes from essentially from providing engineering services, but more recently to these kinds of big projects where we have done some pretty great engineering design. But now we're mostly focusing on new mobility concepts and on developing new mobility ideas based on ICT systems. So I give you here some examples, and I'll be focusing mostly on the MobiMe platform, which is the product where I'm working. So MobiMe, well, first of all, MobiMe is a platform that has recently been awarded as one of the top 3 best cloud service public sector just recently in October from the Eurocloud community. And what it attempts to achieve is to create a real-time management monitoring architecture for mobility and energy management in cities. So we integrate into a single platform, or if you want to say in a single reference architecture, physical mobility, information mobility, based on enabling new clean energy solutions. So how do we do this? How do we bring users and citizens closer to cities themselves? Is acknowledging the diversity of things, of sensors, of devices, of operators, and knowing how we can create services on top of all the things we have available now in our cities. So I come from the EV charging management project in Portugal. That's where we started. So right now we are enabling new services for even traditional approaches like parking with virtual parking management, or how do we tackle the issue of traditional public transportation, and most of all, how do we create new services for sharing? So bike sharing, car sharing, either corporate or public schemes, or motor sharing, all those kinds of sharing services that nowadays all the cities seem to want, but we still lack the business models or the way to really integrate them all into the city ecosystem. And of course, in the end, it's all about the user and getting the user in control and getting the user to have all this information, either on his app, on his smartphone, or on his car, which if you like it or not, we will always have, or still for the next few years, we will always drive our own cars. But these cars must be integrated into something greater. So first of all, these three vectors are easy. So our aim is to tackle the reduction of mobility costs, the reduction of times, of course, commuting times, which are a great cost also for cities, and reduction and the monitoring of the ecological footprint. Okay, so being able to account for the change that you are doing and saying, okay, this is the impact that we are causing, this is the way to go. In the end also, we as CEIIA, we try to promote the concept of mobility as a utility, meaning that you'll get, hopefully in the very near future, the approach to integrate mobility billing, all the natural service that you see today, but also working on end-to-end services such as, for instance, insurance companies who want to create pay-as-you-go insurance services, or other kind of actors who, by integrating all of these things in your city, you can get new services from. So the basic idea behind our approach and behind this architecture is acknowledging that we are not creating a product or a platform to a given sector. In fact, we must always be adding on what we've built. So cities for me are not, cities and users are not the customers or clients. Cities and users are those guys that should have control and information for free. So let's try and build let's try a bottom-up approach, try with small pilots, small projects, and try to provide this information to the citizens, to the users, and see how they use it. And also, of course, by integrating all of these guys, you get the emergence of new players that are global mobility operators, people that are not even used to working with mobility, but see value in the new service they can derive from this information. So of course, this platform must be designed for handling billions of transactions. And of course, we're starting to develop ourselves, but also with partners, solutions for new approaches to mobility. Okay, so these are just the ones that we're working on, but several others will surely follow. What I will show you right now is just the examples of how we are introducing new mobility concepts through innovative products and services. So these are examples that we prototype and then work in different cities and with different partners. So of course, we started with our fancy monitoring center for mobility and smart cities in Portugal. Firstly, for the mobility charging network, now for a whole different set of services. We've created a new concept for home mobility devices and for the concept that mobility must start the moment that we leave our places. So how do we provide information for users the moment they wake up, the moment they decide to leave the home, and how they will travel, if they'll take the shared car, if his electric car is available for use, or if you'll take the bike. And regarding bikes, we are also presenting here what we call a social network for mobility devices, which basically is done by enabling also vehicle-to-vehicle communication for bikes. So this could be the traditional use cases for marketing, geo-based marketing, but also for instance, recognizing the person that's just coming towards you, and maybe you know him, maybe that guy has some common interests, maybe there's something that connects you. So how do you create social networks that are not only based on people and how you proactively interact with them, but how does the way you move reflect and can be a means for interacting with other people and all the different devices. We are also tackling the subject of creating the new service stations for our cities. This is an example we will be very soon opening in the city of Porto. The new mobility hubs will have to be green, of course, and we have to have the buses, the taxis, the sharing stations for bikes and cars. What's the new urban landscape when you take these new kinds of services? This is the car that we actually presented last year, so the concept of a car as a service. This is a new project we're trying to industrialize also in Brazil. So it's a connected car with a lot of fancy controls over your tablet. But the idea here is what can you get by connecting cars and having embedded intelligence everywhere. And a very good example was just presented what we can do with that. And also of course, we need to have means from bringing and giving intelligence to all of these devices, and we're also working on how to better connect them. So from a strategic point of view, we are working very much in Latin America, mostly in Brazil, and these are the examples that I would like to show you. So we develop in Portugal, but we try to create as much with just 250 people. I guess like 40 or 50 people work in the subject right now, but we create local partnerships with companies and with cities to try to develop the concepts together. So in Brazil, we are working with the city of Brasilia, the capital city, also with Curitiba, which is our most interesting project, where we actually design a vision for Curitiba to reinvent itself. Since, as you probably know, in the 70s and 80s, Curitiba was a global role model for urban and mobility management, but nowadays it's a city with most cars per inhabitant in Brazil. So we're trying to reinvent how Curitiba, with mobility as a utility, can in 2020 be once again the role model for mobility management. Of course, so we all like Rio and what it has to offer, so we also have a social responsibility project going on in Rio, but several other initiatives we are working on integrating new sharing services also for the city of Rio. But if there's one thing that I'd like to point out is the partnership we've established with Itaipu. For those of you who don't know, Itaipu is a binational company between Brazil and Paraguay, and they're actually the world's largest producer of green electricity. So they have this huge dam, and we have just designed a lab for mobility experiments within the dam, where we have car sharing going on, where we have new concepts for the integration of mobility with the energy networks. And from that lab, we are going all over the Brazil, hopefully also Latin America. Okay, so this is once again the example for our project in Curitiba. We'll be presenting later on this afternoon also this project in detail. But these are the main concepts and our partners. We are working from the very first stage on urban logistics with the post office, for public security monitoring, traffic control, tourism. On a second stage, we'll be including taxis, and then on and on with public transportation and some bike sharing, car sharing schemes. All of these until 2020, where we will get everything connected. So these are just some project indicators. It actually started in World Cup this year. So it was kind of a marketing event in the beginning. Right now it's getting some traction, and you can take a look at some of the figures. You'll see for us CO2 tracking is very important, pollution tracking. Also the financial impact of the project is very, very relevant, both to the end user and also to the municipality. So of course we have to have different kinds of systems. I'm just going through some of them. So we have to track all of these devices, be them cars, charging stations, bikes, taxis, whatever. You get also, for instance, this is a project we are also doing with the city of Porto by tracking in real time the entire, by working with them for the tracking of the fleet of buses. Here you have the entire municipal fleet also for the city of Porto, which is tracked in real time, and you get these fancy heat maps for knowing how these guys are moving and how can we better know about mobility at the city level. So, and in the end, you need to have the apps. You need to have the apps where you have the different services available. This is an example for the city of Curitiba, where you have those services available right now. Okay, so this is just a quick journey that I've showed you what's going on, how are we working on the subject. I would invite you all, if you'd like to visit our stand, we'll be happy to give some demonstration, talk a little bit more about what we're doing in Brazil, and that's basically it. Thank you very much.
Okay, thank you very much for the presentation. There are some seconds left. A very quick question, unique question. No questions. Okay. Thank you very much. And then we move to the last presentation this afternoon by Mrs. Kiva Allgood. She's the leader for Qualcomm Smart Cities initiative and helps cities build long-term connectivity plans and strategies that help improve the livability, sustainability, and connectivity fabric for citizens. Please.
Thank you very much. Good afternoon. Loved all the previous presentations because the one thing they kept talking about was connectivity, and connectivity is near and dear to our heart, maybe. Oh, somebody more intelligent than me is going to fix it. So I'm going to start off with an overview for who Qualcomm is and what we do. A lot of people, how many people in the room have heard of Qualcomm before? Okay, wow, not very many. So Qualcomm is a leader in connectivity solutions, and we define connectivity in several different ways. But first and foremost, it's really the enabler behind a lot of the things that all these gentlemen just highlighted. So if you think about mobile, the majority of the phones in this room, because they look like they're pretty new, have Qualcomm silicon inside. So if you think about a Snapdragon, we're the heart of the apps processing and the capability behind the actual smartphone. We also have connectivity solutions in the majority of the computing applications that are out there today. We also have consumer electronics. So how many of you have a router in your home? Now everyone's... We're the number one silicon provider for all routers as well. So again, Qualcomm has a broad-based products, anything from Wi-Fi to cellular, but the key is that they're really wrapped around the use cases that you just heard about. So if you think about vehicle to vehicle, vehicle to pedestrian, vehicle to infrastructure, they're all based on the premise that the information can get from one place to the next seamlessly, reliably, and securely. So that's where Qualcomm's specialty is. And we love to hear these use cases because, again, we firmly believe that the more tightly integrated the information is with the infrastructure and those specific use cases, the more intelligent we'll all become. But you have to be willing to do something with the information. So again, surge of connected devices. One of the key things that we're focused on at Qualcomm is the fact that today, 50% of the population lives in cities. By 2050, 70% of the population is going to live in a city. And that has a lot of implications for municipalities and people who have to plan for that. So that also means that there's more people who are going to want to connect. They're going to want to watch a movie. So that means more connectivity and more diversity in the type of solutions that we're bringing to the cities. So that doesn't mean everything is going to be cellular. It also doesn't mean everything is going to be fiber. I thought that was a great question. It's going to have to be a heterogeneous network. It's going to have to be all of those things working together as seamlessly as possible without stepping on each other and pushing each other out of the way. And that's something that Qualcomm is really dedicated to within the smart city space. It's really redefining that landscape. So if you're putting a light post in, the light post needs to have more than one purpose. So if you think 10 years ago, your phone had one purpose. It made a phone call. Now today, it's your babysitter, it's your matchmaker, it's your entertainer, it's your music maker. So we really firmly believe that infrastructure should do that, have the same purpose, and really transform cities into the future by having multi-purposes. So if you're putting in a light post, that light post shouldn't just provide lighting. It should be an environmental sensor. It should be an alert to a car not to hit it. It should also, potentially be a small cell so that it can provide backhaul and connectivity solutions for the city. So that means all of those different types of connectivity solutions can live in one thing versus having to be, if they're thought through and they're planned, versus having to be added on at a later date to enable all the different use cases that we've just talked about. So again, these are some big words. Since most of you didn't know who Qualcomm was, probably these won't make a lot of sense either, but the key point is that it is going to be a heterogeneous network, and that's really the goal for Qualcomm when we talk about an intelligent, smart, and connected city. So what are the other things that we really think are critical? The other one is that it has to be an open framework. So proprietary mesh, anything with the word proprietary on it means that typically there's only one or two people who can provide that solution. And unfortunately, if one of those two people no longer is in business. We've been working with a lot of municipalities that have had to rip out solutions because the person they got it from is no longer there and dedicated to keeping that network up. So if you think about a cellular network or you think about any type of network, it's a lot of work because people don't typically complain when it's not there, but as soon as it goes down, you're sure going to get a phone call. So operating a network is a very expensive investment and something that you really have to think about before you jump into it. So again, we think that leveraging the current systems and technologies that are out there, IPv6, 802. Any flavor you'd like, all the GSMA and 3G standards, those are the way to go instead of actually going onto something that isn't open and isn't interoperable. So standardization. The other piece is the ecosystem. And we firmly believe that that ecosystem includes people. So some of the best applications we've seen to date have actually been where the citizens have stepped up. So, you know, the city no longer has the budget to fix potholes anymore because they had to cut down the team from, 20 to 2, but they launched a citizen app that allows people to report where the potholes are. So now the people that are left can really focus on fixing the potholes and those mobility issues versus driving around and trying to find them. So citizen engagement, it needs to be part of that ecosystem. So it's not just app developers, it also is the people who are living within the environment itself. And the last piece is flexibility. And the flexibility comes, I think, from my own personal view, with the open and interoperable. So you'll be more flexible if you're very clear on what your ICT standards are, if you understand how all of those different things work together and they're able to communicate across the board. That allows for that flexibility in the overall system. So when we talk about connectivity in intuitive cities, it's not just that you're going to get a notification of where the bus is. It's actually you're going to know that there's a seat on that bus. So you're not going to leave your desk until you know that there's a seat on the bus or you know that there's a place to put your bike. So again, it's elevating that sensing beyond just saying, hi, I'm here. It's, hi, I'm here and I have a seat. Or, hi, I'm here and there's a place to put your bike. And that actually requires some programming and additional intelligence. So it's a lot of the cities and municipalities we've worked with have said, hey, I don't want all the information if I can't do anything with it and I can't create something for the people who want that. And that's the intuitive side of things, which implies that you're going to have some edge processing and edge processing capability beyond just the initial sensing itself. So in smart transportation, we've been doing a lot of different work on projects, a lot of which were highlighted here. So we have one of the most advanced DSRC roadmaps, which is the type of technology that allows you to do the vehicle-to-vehicle and vehicle-to-pedestrian communication and the ADAS stuff that you were highlighting. So again, it's all based off of a lot of the silicon and the protocols that we've been working on. But from a category perspective, what are the areas that we really see cities talking about and asking and looking for? And this is because typically it's got a high carbon impact. Secondly, it's something people complain about and care about. And last, it's really where we see the future. So if you think about smart traffic, again, it's knowing where there's a parking space or knowing if there's an accident. And one of the most popular apps in the United States, which is Waze, again, crowdsourcing. It tells you where the police officer is so you don't drive down that road so you don't get a ticket. So again, it's the engagement of the citizens in connection with the intelligence on the vehicle itself. And smart charging, Qualcomm has a product called a Halo, which is a wireless charging solution. So we are sponsors of the Formula E as well, so you will see Qualcomm participating in both those. But we're actively really looking at the evolution of charging, both from a cell phone perspective as also to a vehicle perspective. And then smart mobility, and I think these guys nailed that. It's really around how do you allow for multimodal solutions. So how do you allow people to really move around the city as effortlessly as possible, from payment to location to single starts and stops. All of those things are super important. And I do think the more intelligent we become, the true desires of people and how they want to move, the better opportunity we have to be able to provide those solutions. And last is smart parking. I actually think Dubai nails the smart parking piece because they don't even have a parking meter. You take a picture of your license plate in the spot and it charges your credit card. So there is no infrastructure in it. But I think the evolution of parking, especially in spaces where you don't have that type of luxury, is something that we're also investing heavily in. So that's the overview for Qualcomm and what we're doing in the mobility space. But I'd love to take questions because I have a few more minutes. No?
The previous presentations, we have now plenty of time for many questions. Please.
No?
But given that we have time, if there are some questions for the previous presenters.
Easy crowd.
Then, if there are no questions, that concludes our session. Thank you very much to the presenters for the interesting presentations, and thank you all of you for your attendance. Bye.